the idea of inheritance is that we take, if we have classes that are very similar, we take the common. This is the keyword you should keep in mind. We take the common attributes and methods, and we put them in the superclass, and then we inherit them in the subclasses. And the reason we do this is to increase reuse, is to be able to do reuse. And the second advantage and second rationale why we do this is to ease maintainability, is to make maintenance easier. Because we don't have code duplication, thanks to inheritance. If something changes, we only go to one place and change it, rather than finding where we copy-pasted some common code and we change it in multiple places. And this is very, very important when it comes to maintainability. So the topic of inheritance, we have two major things. You need to understand what inheritance is, why we need it. You need to see a lot of examples of inheritance. And then you need to understand something called overriding, where the subclass can change the implementation of some method in the superclass. I will explain what this means. And there's another topic which is called polymorphism that I will explain in the next session. Just to keep this one slim, 20 slides. The next topic will be much more richer. But those are the aspects when you talk about inheritance. Those are the major ideas. So, as I explained, we have the common attributes and method in the superclass, and the subclass inherits them. But the subclass can also add its own attributes and methods. And not only this, it can also extend or override the superclass methods. So the subclass can go to the superclass method and change it, change the implementation of it. I will show you examples of this. In terms of the way we do it, in terms of syntax, we just create a class and say extends, and we put this to the name of the superclass. And that's it. And why we're doing all of this? For reuse and for improving or making the maintainability easier, because we have less code duplication. Now, once you know the concept, immediately you have to jump to examples. Otherwise, the concept will not be clear and you will not be solid understanding until you start seeing a lot of examples. So here is the first example. In here, I have a circle as the superclass and the cylinder as the subclass. So circle and a cylinder, as you can see here, I have radius in the circle and I have the radius in the cylinder. So this is something common. There's also the color. Let's say the background color is white in both, for example. It's an attribute, it's a common attribute. So those are the common attributes. And then we have a get radius and get area. Those are common methods. Both of them have these two methods. And then the cylinder comes in and say, oh, no problem, I can inherit those. I don't want to spend time implementing them again. But for the cylinder to work, it needs extra attributes. In this case, the height. You see this height is specific to the cylinder. We don't find the height in the circle. So it will go ahead and add the height. And then it says, okay, because I added the height, I need the get height method, which is a new method. And also, even the cylinder constructor, I need a constructor that takes the radius and the height in one go. And then there is an extra method called get volume. It only makes sense for the cylinder. The circle does not have a volume. Yeah, so that is the idea. So there are some common things between the circle and cylinder. We push them up to the superclass and we inherit them. And then the subclass will have specific attributes and specific methods. Is clear? Now, notice that the constructors do not get inherited. So each class has its own constructor. But the good thing is, in the constructor of the subclass, I can call the constructor of the superclass. Remember this? Yeah, by using the super keyword. Okay, so this is example one. The circle and the cylinder is a good example of inheritance. The other example we kind of tried to do together last time is between the person, the student, and instructor. So the student let's say in a QU context, we have QU member, maybe the member is the common. So we all have ID, first name, last name, email, mobile, address, and so on. But each member, depending on their category, they might have extra attributes. So for example, for student, they have GPA as an extra attribute. And for the instructor, they might have office as an extra attribute. Okay, so that's the idea. We put the common things in the superclass and we inherit them in the subclass and we can add some extra attributes. All right, this is third example. Employee. We have an employee in a company like or an organization like QU. We have employee. Same concept, lots of things are common. ID, first name, last name, email, phone, and so on. But we might have a full-time employee and part-time employee. So full-time employee, they have a salary and an office number. Part-time employee, they don't have a salary, they have an hourly rate. Okay, and they might even have the number of hours worked per week or something like this. Oh, no, sorry, that's not part of the employee. It could be part of the payment. So when we want to pay them, we will find out how many hours they worked, and then we will multiply the hourly rate with the number of hours they worked. Now, for a full-time employee, there is a salary, even if they stay up to midnight or they leave at, they check in at 9 and escape at 9:30. That's it, they have a salary. Yeah. So you can see here the difference between the two. Okay, so the UML symbol to do this is this empty triangle, and it's called generalization. It's another name for it. Because if you think about it, an employee is a generalization of part-time and full-time employee. Okay? Another name for this symbol is that the part-time employee extends the employee, and the full-time employee extends the part-time, the employee class. Is clear so far? Okay, good. Now, moving on. Plenty of other more examples. Of course, you should be familiar with them conceptually, but also practically, that I will jump shortly into the coding to show you how this is practical. So here, for example, students. Even for students, you might have multiple students, multiple subclasses. We have a graduate student, undergraduate student. We have shape, circle, triangle, rectangle, sphere, and a cube. Loan, we have car loan, home loan, mortgage loan. Employee could be faculty or staff. Bank account, checking account, saving account. And the list goes on. So those are examples. So that what I'm trying to say here, always learn the concept, learn some associated examples, and then you stop there, jump to apply it. If you don't apply it, as if you never learned it. Okay, now, any more here? This one I already discussed. Super important to keep this in mind. To be able to distinguish between is a relationship versus has a relationship. Yeah. I think even even I think Maryam, she wanted to give an example of car or something, and then said, "Oh, no, this is not an is a," and then she stopped. Okay, so it is more has a. So we have, let's say, car and engine. We'll say it has an engine. It's not like an engine is a car. Okay, but all the examples I gave you here, I can validate them using an is a question. Is a part-time employee an employee? Of course. Full-time employee, is it an employee? For sure. Now I validate. You see here, is a cylinder a circle? Kind of circle with some extra features. Yeah. But it is, at the end, you can think of it as a shape. For example, here, graduate student and undergraduate student. Graduate student is a student. An undergraduate student is a student. And the checking account, saving account, those are still bank accounts. So just keep this in mind. Always for inheritance, make sure the subclass is a superclass. And don't fall into the trap of considering as an inheritance. So those are either aggregation or composition or simple association rather than inheritance. So it's very easy to validate. You validate it semantically, I mean, in terms of meaning. The program or the compiler does not care whether you you do some nonsense, but it won't be able to verify. This is more in terms of meaning. You need to verify that this subclass meaningfully is a superclass, is the same as the superclass in terms of meaning. Okay? Okay, I think I'll stop it here and then I'll jump to some examples. So here it is. So what I have here, I have an inheritance hierarchy. So what I have a shape, and this shape has common attribute, which is color, and I have get color, set color, and get area. There is also get area, which is common. Now, the circle extends the shape. How does it extend it? By adding the radius, by adding get radius and set radius, and also by adding this toString. But anyway, this toString is a little bit strange because this toString is also coming from the object. Okay, let me introduce this. This is just specific to Java. In Java, the Java people, when they design their language, they make every class will implicitly, automatically inherit from this class, built-in class in Java called object. So every class in Java, whether we like it or not, whether we don't need to do it, as soon as we create a class, that class automatically inherits from object. Now, object class has one method called toString that I will explain shortly. So what this circle is doing is basically changing the toString method belonging to the object class. Okay? Now, what the cylinder is doing, the cylinder is taking the superclass, it's extending the circle class. How is it extending it? By adding this height, by adding this get and set height, and by adding this volume. Can you see here the volume? And also by re-implementing or changing the implementation, or what we call the technical term, overriding the implementation of toString. Okay. Now, let me show you. Here it is. Here is my shape. Don't worry about this. I will come to it. The shape defines a color, defines two constructors, and the get and set. Very simple. Now, if I go to the circle, how do I make the circle inherit from shape? By using this keyword extends. And then it says, oh, no problem. I will be inheriting the color from the superclass, but I will add my own attribute, in this case, the radius. Then in the constructor, I provide two constructors in circle. One is, if you don't specify any color, you just go ahead and create a circle without providing any parameters. By default, what you will get a red circle with a radius of 2.0. Okay? Now, you remember the color attribute belongs to the superclass, which is the shape. So instead of taking the responsibility of initializing the color, I'll ask the superclass to do it for me, to initialize the color. So how do I ask the superclass to initialize the attribute that I cannot access? Remember the color will be private, so even the subclass will not be able to access it directly. Of course, it can access it using get and set. It can do that, but directly no, because it's private to the superclass. But what we can do here, we can call the superclass constructor. By the way, the constructor you cannot directly call it, except in this scenario. The subclass can call the constructor of the superclass. How do we call the constructor of the superclass? By adding super and then passing the parameter. So what this super will do, it will basically call this constructor. It will take the color and set it and assign it to the color attribute. Yeah, that's all it's doing. Okay, where is the circle? Yes. Okay, now if I have two attributes, another way, this is another version to create the circle. If you happen to have a radius and another color and a color, then you pass it when you create the circle. And then for the color, we will give it to the superclass constructor to initialize it. And for the radius, we will do it ourselves. We cannot ask the super to do it because the superclass is not even aware of it. Yeah? That's it. That's the idea. The rest is common. You already know how to do get and how to do set. There's nothing really super. Now, what I'm doing here, although you can see here in this diagram, there is a get area here. Can you see it in the shape? But in the circle, what I'm doing in the circle, I'm going to that get area and changing it in the sense that I am implementing it in a different way. So what is the circle of what is the area of a circle? I'll open my textbook. It will say radius times pi. That's it. That's the implementation. Now, if I want to remind myself, this is optional. I can add this annotation. We call this annotation. At override. What's the role of this keyword I'm adding there? Two roles. The first one is I'm just reminding myself that this method is also defined in the superclass. But what I'm doing in the subclass, I'm overriding it, basically replacing it with my own implementation. Yes? Okay, the other advantage, more important, if by mistake, I have some mistake in the name of the method, then the compiler will pick this up and say, you are asking me to override a method, but that method does not exist in the superclass. So you must have a mistake in the method signature or the method name and parameters. Okay?
How does it know that it should be overriding, not making a new one?
Because I added this key. You see here, if I put,
override,
yeah, it will work. Without override, you are creating a method called get r. Okay? No problem. You have the right to name it the way you wish, even if it's not meaningful. Yeah. But this way, what was your intention? Is to override the get area of the super. Okay. If you don't use this little hint here, the compiler will not help you. The compiler will think you are creating a new method. But as soon as you declare your intention to the compiler, you say to the compiler, oh, by the way, this method, my intention is to do what? To override the method in the superclass. Then the compiler will say, this method does not exist in the superclass, so you must have some mistake there. And you say, oh, yes, you're right. Here it is. It's just coffee time. And then that's it. Is the compiler happy? Yes. So it's a good practice for the methods that belong to the superclass. Okay? And then you override them. It's a good practice to put at override on top of the method name. Why are we doing this?
So that if there was a mistake in the signature.
Yes. If there is a mistake in the method signature means the name of the method or the data type and number of parameters, then it will shout at you. Then it will say, no, this method does not exist. Also, it reminds yourself that you are overriding it.
Is this considered as commenting or not? Is annotation a commenting?
This is not a comment. This is basically.
It's considered as a part of the code?
Yes, part of the code. Yes. At compile time, like you see here, because it is part of the code, if I put something else, it will not override. For example, the compiler is not making sense of this. Yeah, so it's a reserved word. Yeah. Okay. But the intention of it, this has nothing to do with the runtime. This is more as hints for the compiler to help me. If I make a mistake in the signature, it will tell me, wake up, what you're trying to override does not even exist. So open your eyes, go and get your coffee, and don't say nonsense. That's what this is trying to help me do. It's clear? Okay. That's what override means. What override means, I'm basically replacing the implementation of the parent with my own implementation. Is clear so far? Okay, the rest is also in here. Can you see here the toString? Remember the toString belongs to whom?
To the object.
To the object. Now I can also remind myself here and say, oh, this is an override. Yeah? Now if I make a little mistake here, the compiler will shout, will say, what are you doing? There is no such method in the whole hierarchy, inheritance hierarchy. It's not in the shape and it's not in the object. Khalas, it doesn't exist. You are trying to override something that does not exist. And then I will wake up to myself and say, oh, this is supposed to be this. And then the compiler is happy again. It's clear? So before I move any further, let me just explain this concept that every class inherits from object. Let me explain it. So let me go here and create a class. I will call it calculator class. Yep. It is blank. There's nothing in here. Nothing is implemented. I'll go to here. Let me just put this one here because I want to exit immediately. So what I'll do, I'll create an instance of calculator. So here is calculator, calc equal new calculator, yes? And then as soon as I do calc dot, I get some methods. Did I define anything in calculator? There is nothing in calculator. I showed you. There is really nothing. But magically, when I go to the object dot, I get some methods to call. There must be some magic going on here. What is the magic going on? Yes, basically every class, even if you don't write it, it's as if you are doing something like this.
Is it optional?
Not optional. This is like inheritance, forced inheritance by design. Yeah, by design, when you do class, you create class by design. What Java does, by design it is inheriting from the object. Yes, by design. Okay. Now this is please.
Is the constructor also inherited? Default
Remember the constructor does not get inherited. The constructor, what we can do with the constructor? We can call it from another constructor. I cannot call it from anywhere. I cannot, for example, in here, let's say I have here add int x, int y, and this one is public int. And in here, I can say return x plus y. Yes? Now, this is a method belonging to the calculator. I cannot say here super, with the lowercase. I cannot call this constructor. Constructor of the superclass can only be called in the constructor. Cannot be called anywhere else. Yeah, is clear? Okay. So, and it must be the first statement in the constructor. First statement. Yeah. So, for example, let me just to make this clear. So, if I come here, you see here I'm calling the constructor of circle, which is basically the shape. Now, this can only be called within the constructor, and it must be the first statement. If I put it here, the compiler will be upset. See here? Constructor call must be the first statement in the constructor. This is by design. This is how it is designed. So the constructor cannot be called directly except in one scenario. the child class can call the superclass constructor using super as the first line of the constructor. Otherwise, you cannot call the constructor. Now, of course, the other way to call the constructor is when you do the new. When you create a new, when you come here and create new, of course, in here you are calling the constructor. Other than that, you cannot call the constructor directly. Yes, please.
What about the other way? Can we call the constructor of the, for example, if we are in the superclass and we want to call the constructor of the child class, can we do that?
No, because basically the parent is unaware of the child. Remember, the parent is unaware of the child. Can you see here the definition of the parent? Here is the definition of the parent. The parent has no idea that there is a child called circle or a child called, what is it? Circle or cylinder or anything. Okay, it's not aware of it. But the child, why the child is able to call the parent? Because it's aware of it. Because in here, can you see here? When I put the circle, I say extend shape. Khalas, once I do extend shape, then I have this super keyword. I can use this super keyword to access the parent. So I have a reference to the parent, but not the other way around. Yeah, because the parent is not aware of the child.
And the super, since the original constructor for the shape starts with the color, we should put the same.
That is not specific to this. Basically, when you are initializing the object and putting some parameters, you have to follow the order of the parameters. Otherwise, it will not make sense. Yeah, that is the idea. Yes. Okay. For example, in here, employee, I have here first name, last name. When I create an employee instance, I have to provide first name, last name. If I inverse them, then I'll be putting the last name in the first name and vice versa. So this is not specific to inheritance, this is general. When you call a method or create an object, you have to respect the order of the parameters. Otherwise, you will have a behave that is not what you expect. Okay, moving on. So here it is. So let me go back. Let me go back here just to show you. Even if I have nothing in here, plain, empty, zero, nothing is there, I have still some methods here. Yep. One of them is, for example, get class. What do you think this will give us?
Return the class.
Return the name of the class of this object. What is the name of the class of calc?
Calculator.
It's calculator. But it will put the name of the package dot the name of the class. Yeah. Now, another thing I can do, I can also do here calc dot get toString. Yeah, toString. What do you think I will get if I do toString? I get the class, by default, I get the class name. I get the class name, and then I'll get at some number. I still have to figure out what that number is. I didn't have the chance to do so.
You have the location of the instance?
In memory?
Yeah, memory.
The problem, maybe the problem I tried when I run it multiple times, I get the same number.
Oh.
Yeah. Anyway, let's have a look. Let's have a look what's going on here. You see this first line, what it's giving me? The full name of the class, including the package. And the second one, is giving me the full name of the class with at. I thought that this is the memory location of the object, but it didn't make a lot of sense to me because when I run the program multiple times, it's not supposed to be the same. You remember, because if I close my computer and come back, the address should be different. Even if I run it multiple times, the address should be different. So maybe it's not an address. I'm not sure. We will not really sure. I will check it. But in all cases, this is not very useful. Usually, what I will do as a child class, the child class very often they override this toString. So what override means? I can come to my my class here, and I'll do here public string to string, yes? And then here I will return, for example, whatever, hello from calculator class. Okay? Now, if I want to just remind myself that this is not really my own method, I'm just overriding the method belonging to the parent, how do I remind myself and get the compiler to warn me if I make any mistake? Add override. Yeah? Now, the advantage of this, if I change the signature, even if I make it like this. Now, the visibility, what is the visibility of this method now? Only in the package. Remember, if this is the default visibility, the modifier. Remember the modifier? This will become only visible in the package. I cannot change the visibility of a method that I override. It must be exactly the same signature. Yeah? So that's why the compiler is warning me, saying, see here, override cannot reduce the visibility of the inherited method. Yes? Now, if I don't have this override here, compiler is not even aware what I'm doing. Now let me save. Cannot reduce the visibility. Oh yeah, of course, it detects this. Yep, it detects this even without this. So this one is detectable because there is a two method in the superclass, and basically you're giving the same name, but with reduced visibility. This is not allowed. The visibility shouldn't, you cannot reduce the visibility from the child.
Have to be the same.
Have to be the same. If it is, let's say, protected in here, protected. Public, public. That's it. Okay? Default.
For the methods, right?
Yes. Methods and attributes, exactly the same. Okay, is clear?
So this class is inheriting from object class,
Yes.
right?
Every class is inheriting from object class, yes. And what I'm doing here, I am overriding the toString. Yeah. Now if I come to my test here and rerun it, what I will get? I will get the hello from calculator. Yeah. The other thing here, just for your information, if I'm interested only to get the class name, I can say get class, then get simple name. Then this will only give me the class name. Yeah. Okay. The other thing I want to show you, if I just do print line and don't put the toString, I will get exactly the same as if I put the toString.
Why?
This is by design. If I print an object, by design in Java, if I print an object, it will automatically call the toString on that object. By design, yes? So when you are printing an object, you don't need to specify toString if you don't want to. You can if you wish. But even if you don't put it, by design, when you print an object, what will happen? You're printing the string representation of that object. Sorry, get area. It was originally defined in the shape. And what I'm doing in the subclass, overriding it. Okay. So nobody is curious to know what is the implementation in the superclass area. Can you see the implementation? There is this weird word here, abstract. There is no general and common formula to give you the area of any shape. If you open your math textbook, you will not find any formula out there that you throw at it any shape and it will give you the area. The area depends on the actual shape. Yes? So, if there is a method, it's common method. All shapes will have get area, but there is no common definition. When there is no common definition, what I do to that method that has no common implementation, I mark it as abstract. Why did I mark it as abstract? There is no common implementation. Who will implement this? The subclass. Each subclass will have its own implementation. Once a method is abstract, Let me show you. If I remove this and I save, take a look at this, take a look at this. Once a method is abstract, the shape, once one of the method is abstract, what happens to the class? It must be abstract, otherwise the compiler will be upset. I come here and I try to create shape 1, shape 2, let's say, equal new shape. You see here the compiler? Share cannot be resolved. Cannot instantiate the type shape. Sorry, not share. Yeah? So an abstract class you cannot create. You cannot create an instance of it. Why you cannot create an instance of it?
It's not all of the.
It's not complete. It's incomplete. But I can use it as a data type. Take a look at this. I can use it to create a circle. No problem. So I'm using a complete class, creating the circle. There's no problem whatsoever. And in fact, take a look at this. By the way, for circle, I can initialize it. So the radius is 5 and the color is blue. Yep. Now in here, I can come here and say, shape 2.getArea. No problem whatsoever. This will work. Take a look. If I run this, here is the area of that circle. Can you see what's going on here? So I can use the abstract type, the abstract class as a type, no problem. But I cannot use the shape class, the abstract shape class. I cannot use it to instantiate an object. I have to use one of the concrete classes. Are you following? Yeah, that is the power of this. Let me show you one more thing, and I let you go. Here it is, here it is. So if I come here, and I create, in this case, not a shape, I will create a cylinder, yes? Cylinder. And the cylinder, what does it take as parameters? Yes, thank you. This is the radius. The radius is, let's say, 5 and 4, as an example. Yeah, and I can come here, this is shape 3. And I can come here and basically call this one with shape 3. No problem. Yeah, I still have an area. You got the idea. So, and this is what we will be covering, inshallah, next time. This is called polymorphism. So, the same method, different implementation. If I call it on a circle, it has different implementation than if I call it on a rectangle, different implementation than if I call it on cylinder.
But this only happens if it's an abstract.
The typical way, no, it can happen even if it's not abstract. But basically, abstract method means there is no common implementation. There is no a meaningful common implementation. Yes, that's what. But I could have an implementation, like in toString. There's an implementation, but I override it in other ones. But when I call toString, if I call it on a circle, I get different result than if I call it on calculator, if I call it on other class. So this is called polymorphism. Polymorphism, calling the same method on different objects, you get different results.